All right, let's do some scientific notation conversion examples. We've got my phone set up on my coffee cup here. This is the best thing I could do for now. Maybe I can get a little bit fancier in the future, but just bear with me on this. So remember, when we're using scientific notation, most of the time the purpose of it is to write really, really big or really, really small numbers in kind of a shorthand form. So we write it with this kind of exponential notation here. So remember, if you've got a number that is times 10 to some positive number, that means you're going to have a big number and you're going to move the decimal to the right when you're doing your conversion. And if you have a number that's times 10 to the negative, some negative exponential value, this is meaning it's going to be a really small number, so we're going to move the decimal left from wherever it is. Okay, so let's work through these couple examples here. So here we have a number that's in scientific notation, so we're going to convert it to standard notation. So 5.5 times 10 to the 2, this is a positive 2 here, so that means we're going to be moving our decimal place to the right. So the easiest way to do this is to just write down the number that you have, put your pencil on the decimal point where it is, and then just hop to the right twice and fill in your zeros. So 1, 2, here's our new decimal point. We fill in the 0. So 5.5 times 10 to the 2 in standard notation is just 550. Okay? Next example. We've got 2.24 times 10 to the positive 9. So again, we've got a positive number here. We're going to be moving our decimal to the right. So start by writing down your original number, put your pencil on the decimal point, and hop this number of times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's our new decimal point. Fill in our zeros. So we have this big number here. Let's figure out what this is. So we've got 2, 2, 4, and then 1, 2, 3, 4, 5, 6, 7 zeros. 2, 3, 4, 5, 6, 7. So then if we go back and put commas in so that we have a better idea of what this number is, this looks like 2,240,000,000. So 2.24 times 10 to the 9th is 2,240,000,000. Okay, another example. So now here we have a very small number that's written in standard notation, and we're going to convert it to scientific notation. So remember, all numbers in scientific notation have to be some number between 1 and 10. Okay, so that's like, here we have 5.5, here we have 2.24. You couldn't write this as like 22.4 times 10 to the something. You can't do that. It has to be a number between 1 and 10. So you're going to find where you're going to place your new decimal point. It's pretty much just going to be between the first and second actual numbers that are in whatever number you have in your standard notation here. So in this case, we'll start by rewriting the numbers. So 0 point looks like 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, 9, 1. So right here between the 9 and the 1 is where we're going to place our new decimal point so that we have a number that's between 1 and 10. And then we're going to go to our original decimal point and we're going to count how many times do we have to hop to get between the original decimal point and our new decimal point. So let's do this really quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 hops, okay? So this means we have 9.1 times 10 to the, since this is a really small number, remember that's going to mean that we're going to have a negative exponent in our scientific notation. So this is 9.1 times 10 to the negative 10, since we hopped our decimal point left 10 times to get from our new decimal point to our original decimal point. Okay? Moving on, we have another number here that is in scientific notation, so we'll convert it to standard notation. So again, start by writing down the original number, 4.45, And now since we have a negative exponent here, that means we're going to be hopping our decimal point to the left this time. So start at your original and hop to the left 4 times. 1, 2, 3, 4. Here's our new decimal point. Fill in our zeros. So 4.45 times 10 to the negative 4th is equal to 0.000445. All right, here's our final example of scientific notation conversion. So we've got this number here in standard notation. We want to convert it into scientific. So we start by writing down our original number, 1, 6, 7, and 1, 2, 3, 4, 5 zeros. Okay, so remember, here is our implied original decimal point at the end of this number. And so now we have to put it somewhere so that we can get a number between 1 and 10. So in this case, we're going to put it here between the 1 and the 6 because 1.67 is between 1 and 10. So that's how we know to put it there. And then we're going to count how many times do we have to hop to the right to get to our original decimal point. So let's hop 1, 2, 3, 4, 5, 6, 7 times. So this means that this number in scientific notation is 1.67 times 10 to the, since this is a large number, we know our exponent is going to be positive, so times 10 to the positive 7.